So, today we will discuss about the lecture 4 is on dynamics and ocean structures. This is in module 1. Of course, the whole course will be run in 3 modules. Module 1 will talk about fundamentals of dynamics, and module 2 will talk about fluid structure interaction, wave structure interaction, and dynamic analysis applied to offshore and ocean structures. Of course, in module 3 we will talk a very interesting area of research which is on stochastic dynamics. Interestingly, you must understand that this course is actually an online course which is currently registered by more than about 1200 students from at least I think 7 to 8 countries. At the end of the course, maybe possibly in first week of May, there will be an exam which you have got to pass, then you will be given a certificate duly signed by IIT Madras. The certificate will have a unique ID and your photograph, and most importantly your percentile score on the subject. Now, you may ask me what is interesting about this. So far I think in IIT system you would have obtained a certificate or a grade to a maximum sample size for a PG class of this order not exceeding 100. That is the maximum sample size for PG class in IIT, at least in IIT Madras. Now, here you have a denominator of 1200, and this 1200 will include many faculty, many engineers, practicing professionals, many graduates who have already graduated, who have already studied dynamics. Now, when you compete with them, you will really know where do you stand actually. Okay. So, if you are only within a class of let us say 25 who all does not know anything about the subject, standing top amongst 25 who does not know anything about the subject is not great. If you stand on the top 10 amongst 1200 who already knows the subject, it matters something actually, it is very important. This is a golden opportunity. Of course, this lecture is free, online lecture for all these 1200 is totally free. There is only a payment of fees for taking the examination if you want to get a certificate, and of course, there is a marginal price, I think it is only 1000 rupees something. This time fortunately with God's grace we have got a very interesting book on dynamic analysis and design of offshore structures, which is authored by me. This is a Springer release. The price of the book is 103.99 euro. This book is available. Now, if you miss out any lectures or if you are not able to understand anything in the classroom here, I think you can closely follow this book. This book has got lot of detailed explanatory examples. We also do the examples here. It is not that you have to purchase the book for necessity, but this will have lot of tutorials and assignments which you have got to answer. In addition to this, those who are taking this class as a regular credit, you have got to undergo quiz 1, quiz 2 and quiz 3, quiz 1 and 2 and major exam at the end of the semester as per the schedule of IIT, where you will be given a grade separately. So, there are dual purpose here. One, of course, you will get a relative grade within your class. You can also get a global grading with a certificate which is valid in all developed and developing universities and countries in the world. So, this is a great opportunity what IIT NPTEL has extended to all the people. So, this is the first time IIT is doing this under NPTEL schedule. I think you should use this. In the previous lecture 1, 2 and 3, we discussed about different varieties of offshore platforms. Let us quickly see what are those varieties of platforms. Of course, if you have missed these lectures, they are available online, you can see them, and before coming for the next class, please understand them. There are three varieties of structures which we generally have in ocean structural system. When you talk about ocean system, let us quickly now focus only on structures which are meant for oil exploration and production. Now, you may ask me a question, what is the difference between an offshore structure and an ocean structure? The fundamental difference is only in the function. There is no difference in the form. The function is ocean structures are generally designed for variety of purposes, maybe sea walls covering, coastal protection, jetties for berthing, etc. Whereas offshore structures are more complex in nature because they are designed and developed only for a specific function, which is either oil exploration and drilling or production and processing. These structures are off the coast, they are into waters at greater depths. Therefore, the complexity of dynamic analysis of these structures are much more higher compared to structures on the coast, because compared to structures on the coast, they are more or less on the land. So, the dynamic analysis on land based structures are generally philosophically well known in the literature. Okay. The one which is hollow is the one when the structure moves towards water, and if the structure remains floating, it becomes more interesting. So, there are three categories here. One is fixed type, other is compliant type, other is purely floating type. Now, let us quickly see the structural action, the differences in the structural action between them. You may ask me why we are interested in knowing the structural action differences before we talk about dynamic analysis. Dynamic analysis will come into play only when you have the structure ready to visualize. If you have a structure ready to visualize, for example, I have a bluff body, maybe a cube which is resting on the floor, which is considered to be fixed, and a cube which is resting on rollers when both the cubes are pulled by some force or pushed by some force of some magnitude, may be static in nature, you will immediately recollect from the fundamental mechanics that the response behavior of this cube is different from that of cube. So, you need to know the support conditions, the body dimensions, the mass of the system, the rigidity of the system, which we call as stiffness, the forces on the system, and most importantly the resistance offered to the system, maybe from the support, maybe by the body itself, maybe by the environment, what we all call as damping. So, we must have the system in visualization first. So, when we agree that system in visualization becomes important to understand the dynamic analysis, let us get back to the system first. Offshore structures are classified broadly into three categories: fixed type, compliant type, and floating type. Fixed type is similar to this, where the bottom of the structure is rigidly fixed to the sea floor. Compliant type is different from this, where the bottom of the structure is anchored to the sea floor. Now, quickly the difference between this and this is that the structure has some freedom to move, but the structure is position restrained. So, the freedom is not infinite, there is some boundary, there is some limit, there is a restraint imposed on the system by the supporting condition. The third one, of course, is fully floating, totally free. Now, obviously, if I put this as my water line, if I put the same as my water line here, because the structure is floating, you may say how this is floating. The cables or the members can slack, can get tightened. When they float, this structure invokes additional force from the free surface, where the structure does not float, more or less the force on the free surface is fixed. So, the additional forces coming on the member depends on the geometric conditions how the structure is supported. So, if you do not understand this variation between the type of platforms, we will not be able to do dynamic analysis, because we really do not know what are the forces coming on the structure. You may ask me, I am worried about the analysis where the force coming into play. Force is an important component in dynamic analysis. So, 1 and 2 come from the system, 3 comes from the environment, 4 comes from the system and environment. So, there is a combination between the environment and the structure which makes dynamic analysis very complicated. And to add to this complication, the forces acting on the structure are multidimensional. You may ask a question, what are those complex forces which generally act on a structural system which will challenge the structural action of the system? So, let us quickly see what are those forces which has been explained in the lecture 3, but for understanding purpose let us say I will put in general the environmental forces. Some people address this as environmental loads. To start with, from the superstructure, one may ask, sir, what is the difference between superstructure and substructure? Superstructure is one which is above water, substructure is one which is below or in water. Whereas in land based structures, superstructure is one which is above soil and substructure is in foundation. Whereas in offshore structures, the one which is above water is superstructure, the one which is in water or inside water is substructure. We start from the top, we know wind loads, which we had discussed in the last lecture, following by which wave loads. Waves also will have current action, they will also have marine growth, there can be dead loads, there can be live loads, there can be accident loads which is called collision loads, there can be seismic forces, let us put it as earthquake forces. Etc. We have anyway discussed all these things with the respective equations, with the respective spectrum, ice loads, acting on offshore structures. Interestingly, most commonly many textbooks do not touch upon the effect of earthquake loads and ice loads on offshore structures. They are very rare. In fact, they are very scarce in the literature itself. And many books and many research papers will idealize wind loads as non-dynamic in nature. Okay. They make it as equivalent static or quasi static. There are reasons for this, why it is so. We will talk about that as we move on to dynamic analysis. So, we must know that how the structural action of these three are different when the forces are acting. We will take one example, let us say earthquake loads. We will take an example to demonstrate how earthquake load can cause significant difference between the type of structures as a structural action. So, we are talking about only in structural engineering perspective. These forces are not focused in this literature and these lectures like an hydrodynamic engineer. If you really ask me, can you give me the equation of Varieties theory or ISSE spectrum to calculate the wave forces, possibly you have entered the wrong class, you have got to go to some other class to find out this. Okay. As a design engineer, as a structural dynamic analyst, I must be given these loads readily available either in the software or in a code. So, I must know these codes. So, in the previous lecture of lecture 3, all the spectrum related to all of them are available and given in a closed form equation to you. So, how this equation will be derived, what are the conditions, what are the space parameters based on which the conditions are affecting these equations, where are they applied, we just ignore all of them, we are not bothered about that, because that part we are away from this, we are entering into a different domain now. For me, forces is one component in the analysis. Of course, dead load and live load will contribute to mass. Where the rigidity will come from, where the damping comes from, I will explain that. So, now the question is very easy to ask, what would be the difference in structural action of these varieties of platforms when a typical force, say earthquake load, is applied. Once you have a capture of this idea, then you can vis-a-vis apply any one of them in your mindset and see how the behavior will be different. So, please understand, our focus here is not calculating the forces on the structure. Then what is the focus? The focus is what is the response of the structure for these forces. So, very important, we are talking about dynamic analysis, whereas in every analysis problems you will always compute the forces and the displacements. Here the forces are given to you, you should be able to estimate the forces from the standard spectrum. What you do not know is the response. Okay. So, that is why categorically many research papers say dynamic response analysis. The term response is interfered between the dynamics and analysis. Many people say it is dynamic response analysis. When people say hydrodynamic response, they do not touch about the structural response at all. They talk about the variation in the loading, not on the structural form. We are talking about structural response, purely on structural dynamics perspective. Therefore, we do not focus on loads much. This is also an important area of research, I agree, but we are not touching upon in these lectures or modules, because there are some other space where you can study them. Okay. Many textbooks are available, you must have learnt, or you will be learning, or you may not be bothering, we are not concerned about that. Let us answer the question back again. I have a force, a typical earthquake load, I want to apply. First question comes, is a standard spectrum available for defining earthquake load for offshore structures? The answer is big no. People have not given any standard spectrum to calculate the earthquake loads on offshore structures at all even today. Whereas, for wind, wave, current, dead, live, accident and snow load, spectra are available. For earthquake loads, spectra is not. It means the seismic analysis of offshore structures is very, very weak in the literature domain as on today. What is the reason for this? There are two reasons for this. Let us talk about these reasons very quickly. Reason number 1, people initially thought earthquake loads will not cause significant response on the platforms. So, response is insignificant. This is what people thought. Now, there must be a reason for this. Why people have thought like this? The people thought like this because they applied their force only for one variety of platform, which is bottom supported. Obviously, any model or any platform or any bluff body which is bottom supported, when subjected to excitation in all the three axes x, y and z, the platform or the body will respond. But then why people said it is insignificant? Because the mass of the body is so heavy, the response initiated by these forces were damped by water body. So, people thought it is not effective at all, because all the time they thought the response is indirectly related to the stress levels on the members. When complaint platforms emerged in late 80s, where the platform is not resting on seabed, but anchored to the seabed using tethers or cables or tendons, when the platform started floating, then this response statement became invalid. Now, let us see what is the structural action which is evoked by a compliant platform when you apply a seismic force. Let us see, this is my compliant system. Which is held down in position by, I would say, cables. Technically speaking, they are called as tethers, they are called as tendons, etc. So, we must agree that these are axial tensile members. These are axial tensile members. The example what I am showing here is a tension-like platform, okay, TLP. So, these cables or tendons will be in axial tension. I do not know how many of you really know that how to mark a tension arrow and a compression arrow in a given cable member, because this is always a great confusion what people generally have. Let us quickly answer that, because let us say I have a member, I have two nodes. I have a member, I have two nodes, maybe node A and node B. If the member is pulling the node, it is tensile. If the member is pushing the node, it is compression. Remember, it is the action of the member on the geometry, it is not the support on the member. Okay. If the member is pulling the node, it is tension. If the member is pushing the node, it is compression. And I know you will definitely not mark like this. Okay. This is meaningless. It has to either pull both sides or push both sides. This cannot happen. Okay. This is wrong. So, here these members are in axial tension. Okay. Now, I have an earthquake signal applied here. I will take a signal in the vertical axis, a random signal whose peak, ground, velocity or acceleration is known to me, history is known to me, it is given to me by a spectrum. I will come to the spectrum later. Spectrum gives me PGA or PGV, peak ground velocity or peak ground acceleration, time history is known to me. I apply the time history here. The water level is here, this is my mean sea level, mean water level, and I am talking about a depth of about, let us say 1000 meters, great depth, water cushion is there. Let us apply the signal of earthquake force here. The question asked is, will the structure respond? I am all the time bothered about what is the response of the structure. Okay. Here the term response redefined as the displacement, not the forces. Okay. Now, otherwise the structure is moving, it is free to float. So, there is a lot of freedom given to the structure in terms of displacement, but what is that happening to the structural displacement when such forces do apply at the bottom, which is a kilometer down from the point of water level. Interestingly, when the seabed moves up and down, the cables are either pulled or slacked. When the cables are pulled or slacked, the stiffness of the system changes, because there is a change in buoyancy of the system. When the buoyancy system is changed, the response system is significantly altered. Okay. This causes dynamic tether tension variations. So, this is dynamic tether tension variations are imposed on the tendons, which causes response to the superstructure automatically. Now, one can ask a question, what will happen when these anchors or these cables or tendons are removed? That is the third case, which is freely floating. Freely floating. If you have them freely floating, you will not be able to do any operation, because you will be keep on floating. You have got to position restraint this using either a geometric positioning system or a mooring line, which is generally done in the case of a semi-submersible or a drill ship. Now, in such cases also, when the system is moved down for position keeping, when earthquake signals are applied, it will have some impact on the motion of the body, which will affect the production capacity of the semi-submersible. But if you have the drilling risers connected for production, the risers are affected, this will affect pull down of the riser completely, that will loss in production of the system. In all the three cases, earthquake force applied to a variety of platform imposes variety of structural reaction, which is not common. So, what we try to understand here is not the force alone, but the effect of force on the system, which we call dynamic response analysis. So, the variety does not come from the force, the variety essentially comes from how do these structures behave for these forces. So, if there are 10 variety, 3 platform, you have 30 combinations. I have taken a specific example how they behave. Similarly, one can apply any one of these in mindset and see how the structures will behave if you know the structural geometry. So, the most important component now comes in mind is what is the geometry which is important? Is it the size? Is it the member arrangement? Is it the cross sectional dimensions of the member, or is it the water depth? Is it the wave height? Is it the tidal variation? Is it the buoyancy or the variable submergence? Is it the wind force? What is that causing the difference in the action? So, it becomes very important that the structural form becomes very important. See, you must agree, compared to offshore structures, compare this to any land based structures, for example, buildings. Most of the structures are function dominated. I can give an example: an airport, a theatre, a multiplex, a hospital, a school, a library, an institution, an OAT, an ICSR. They are function dominated. So, they will tell you what should be the size of the space available, what should be the arrangement of rooms available. All these are architecturally designed, whereas in offshore structures function domination is not important, it is the form. So, they are form governed systems, because form is the one which either makes it compliant or floating or fixed, it is not the function. Remember, function of all the three are exactly same, all the three platforms are meant for oil exploration and production. So, function is same, form is different. So, form domination will influence three characteristics: the mass of the system, the stiffness of the system, and of course, the damping of the system. One can say, what is about the force? That is an interesting question, because the force attracted based on the form is also challenging. I will tell you why. If a pole is fixed, maybe even both the ends, it will have a tendency to attract more forces. If the pole is free, floating, there is no boundary conditions, free, the force attracted by this pole will be the least. Why? Because the pole will start moving and give way to the force to pass through the pole. It means there is a relative agreement between the structure and the force. When the wave hits, the pole moves. When the wave hits, the pole moves. There is a relative movement between the structure and the wave. So, this relative movement will compromise the force on the member, whereas this structure will not move at all, will attract the force. So, depending upon the form, the force also is governed, but however, depending on the form, mass, stiffness and damping will very seriously vary, there is no doubt on that. So, you may wonder why we are talking about only 4 elements: mass, stiffness, damping and force. These are called essential characteristics of a dynamic loading. If you do not have any one of them, you do not do a dynamic analysis. Okay. These are called essential characteristics of a dynamic loading, okay, or dynamic analysis. If any one of them is absent, the dynamic analysis is not complete. Okay. But there are cases where we study undamped systems, there are cases where we study free vibration, so force is not present, but there is no case where we study mass is not present, stiffness is not present. Now, the question comes, why amongst these 4 these 2 are very important, why these 2 are not important? Because if there is no force, one can say the structure will not move, but the structure is meant not to move because it is freely floating. This is one of the important characteristic of any offshore platform, because this will save lot of time and money in terms of commissioning the platform. The platform should enable to free float on its own. The day you make the platform float on its own, erection and commissioning charges will drastically come down. If you have got to make the platform to float by some means, hooking them, craning, etc., or appending or loading out, the construction cost is going phenomenally high, which was a problem in fixed type. Okay. So, the type of platform will help you to reduce the forces as well as to make it easy for commissioning and decommissioning. I want to remove the platform because I do not find oil in a specific place, I want to decommission the platform. You will now understand many of the fixed offshore structures in Gulf of Mexico is a big menace happening, that how they are going to remove these platforms, because there is no oil well available there. Oil well may be there, but there is no production. So, they have become fascinated structures, that is all. Once upon a time it was constructed, Conoco had a platform, but Conoco does not produce oil at that specific platform. Now, what to do with that? You cannot create a hotel and you cannot earn that much money what the platform was earning few years back. Therefore, US says please remove this platform or pay a penalty to us, because you cannot hold the waters unnecessarily. So, decommissioning becomes a serious problem. The moment you say decommissioning, it results in environmental impact analysis. If you leave the platform there, what will happen to the aquaculture? If you remove the platform, what will happen to the aquaculture? While removing, if you blast, what will happen to the aquaculture? There are many aspects related to even decommissioning also. Okay? So, people are paying through the nose to decommission these platforms. They are trying to find a mean by which this platform can be put to use by some means, so that they do not have to decommission. So, decommissioning becomes very, very difficult, whereas in platforms like this, in platforms like the TLP, remove the teethers, the platform is set to afloat like a vessel or a ship. So, drag the vessel using a tugboat, move it from A to B, you have decommissioned it. So, no problem. So, decommissioning becomes a challenge, and this was not thought earlier when people installed platforms in 1900s. The first offshore well was explored in 1899. In 1912, we had taken oil elsewhere in the world, not in India, but elsewhere. So, this industry is about 100 years old. The technology is about 100 years old, but we are learning it unfortunately at the 100th year. Okay. So, that is the unfortunate part, that is our mistake, but people have been using this technology for many years. So, these 4 components become important for dynamic analysis. Out of these 4, these 2 becomes predominantly important. Why? Because based on these 2 only, I make a mathematical model for dynamic analysis. So, the mathematical modeling is focused on these. Now, the question comes how and why? Why not on these? Okay, that is what you are going to answer. That is called the essential characteristics of dynamic analysis. So, any questions here? Any doubt, any questions? Any questions here? So, the dynamic loading essentially has 2 components. One is the time variant, part of it, the time variant part of it, The second is variation in magnitude. This magnitude may be also variation in direction, variation in space, etc. Okay. So, these two must be inherently present to prescribe a load as a dynamic load. For example, if the load is not time variant, the load cannot be called as a dynamic load. If the load does not vary in magnitude as well as in time, it is a static load. Okay. So, these two should be there. Now, the question comes, any load which is having a very low magnitude, but varies with time, can it be called as a dynamic loading? The loading can be called as dynamic loading, but you need not have to do a dynamic analysis. Why? This is the answer now. The answer is, if you want to perform a dynamic analysis, the most important component to do a dynamic analysis is the inertia force. For example, I have a paper, the paper has got a lot of degrees of freedom to move, and the paper is massless. So, I do not generate inertia force on that, because mx double dot is the inertia force, I do not have mass, I do not have to do dynamic analysis on a paper. Alternatively, I have a huge box which is very massive, but the box does not move, still I do not have to do dynamic analysis, because x double dot is very low. You understand the point? If you look at these kind of structures now, as you move from a massive system to a floating system, mass has been compromised, but motion has been enlargedly very high. Therefore, dynamic analysis becomes very important, least important. It is because of this reason the dynamic analysis in offshore structures was not developed at least for about 20 years when the platforms are constructed. People thought, I have a rigid supported bottom supported system, I do not have to bother about in dynamic analysis, let us do. So, they have been all doing, most of them, quasi static analysis, and the platforms are constructed. When the form started modifying from fixed to compliant and floating, people then realized, yes, the mass is compromised, but the displacement response become very large. So, I have to do a dynamic analysis. It means form governing the magnitude and the time variation, including the mass, is important for doing a dynamic analysis. So, when you talk about this, then one can ask, what are the two basic approaches we have? One is deterministic approach, the other is non-deterministic. These are two approaches we have. Deterministic approach is applied to analysis where you have something called prescribed loading. Then what is the prescribed loading? If the time variation or time history of the load is completely known, I call this load as prescribed load. If I have a prescribed load time history, I do dynamic analysis, I call that as deterministic approach. Okay. I derive all results straightforward. So, forward. So, the answer is closed form solution. So, deterministic approach will give me a closed form solution to all the problems what I am doing for dynamic analysis. When you talk about non-deterministic, it is only an approach, not a method. Please understand, there is a difference between approach and a method. It is an approach, it is not a method. Okay. If the time variant is not known, completely, I call this as random loading. In case of random loading, I generally express the load using spectrum. So, all solutions I do from this analysis will be all based on response spectrum. So, no direct solution, whereas this gives me direct solution. Now, again there is a basic question asked now in mind. Sir, amongst the 11 types of loads we have discussed just now, which are prescribed loading, which are non prescribed loading? For example, dead load, it is fully prescribed load, essentially it is not even dynamic in nature, it is more or less time invariant, okay, because dead load is more or less static, except you do not include the variable submergence effect on the dead load. Live load, more or less time invariant, okay. So, it is a prescribed loading. Wave load, wind load, earthquake load, more or less random in nature. So, they are non-deterministic. Now, you see there is a combination of different types of forces acting on the structure. What analysis should I do? Should I do a spectral analysis? Should I do time history? Now, either way you can convert them into time history and do an analysis, you can convert this into spectrum and do an analysis. This is what we call time history analysis, this is what we call frequency domain analysis. Both are available for dynamic analysis and offshore structures. Both domains are all right. Preferably people do time domain analysis for dynamic analysis of structures, because you have got lot of merits compared to frequency domain analysis, which we will talk about slightly later when we really get into the analysis part in the second module. So, we have learned couple of things in this class. One, how form dominance changes the behavior of the structure, structural action. Why mass, stiffness, forces and damping are important. Amongst these 4 components of dynamic analysis, why mass and stiffness are more important. When I approach to do dynamic analysis, what are the 2 approaches I have, how are they different, where are they applied, where are they applicable. Once we understand this, in the next class we should talk about how mathematically idealize a given system and develop a mathematical model. Because I have to do a mathematical analysis, I must have a model, how to develop the mathematical model based on the so many dialogues what we discussed in these 3 or 4 lectures. Okay. Any questions? Any questions, any doubt? So, you please go through the lectures 1, 2 and 3 whenever you are free, and of course, you have to go through the lecture 4 also. All these lectures will be available to you on the same day, maybe after an hour lapse. Once it is processed, it should be available to viewing, you can download them and see them. And there is an announcement pattern available in the website, you can always post your questions there, which will be answered within 24 hours. Okay. Of course, physically also you can ask questions in the class, nobody is stopping you if you have any questions to ask. So, do you have any doubts, any questions to ask? So, this will have an examination at the end. I request that all of you should register for the exam, because this exam has got lot of certification, has lot of value other than getting a grade in the class, because your competence is 1200 level in the international community, you really know where do you stand. And there is a benefit that this credit of 3 from the certificate is also transferable for any programs in IIT as well as in abroad. Okay. Of course, a grade sheet is also transferable, similar to that, because this course will run for the entire semester for 52 lectures. So, it is as good as a full semester course. Therefore, these credits are transferable for any your higher education programs. So, that advantage you have if you get the certificate. Those who are looking at this course online, it is better that you register for the exam, and you can always get dual benefit. You can anyway get a grade in the course, being participating in the course physically, you can also get a certificate if you participate in online exam. You can get both the advantages. Okay. The textbooks are available. I have given about 140 references, papers and research papers and conference papers. All of them are important. You must see all of them and read all of them. I have given about 8 textbooks, one amongst is mine, myself, authored by me. You have to read all of them. all tutorials are important. You must participate in the class in form of answering tutorials, etc. Then only you will know, understand. The principal focus of this course is make you to understand dynamic analysis, not to make you as a master. If you really know, sir, I have already understood dynamics completely, I am looking for high end dynamic analysis, I think I am sorry, this course will not address that in the beginning, but at the end you will see that you understood high end dynamics automatically. That is a promise. You start with, you will start with a whiteboard. You do not know anything about dynamic analysis, we start from that level, we take it to stochastic dynamics, which many of us do not know, in an easy manner in the classroom. We will talk about that like this.